Welcome everyone. It's super exciting to see you here today joining us. Today we're going to be talking about how AI has made a breakthrough in the diagnosis of mental health illnesses, and we're going to be here from Sverker Sikström, who is a professor in cognitive psychology at Lund University, because he's been doing really cool stuff with computational modeling of language. So if this sounds really confusing right now, I think we're all pretty much in the same boat, but we're going to live from here knowing what this means and seeing how AI can be applied to so many different things and bring value to society. I'm going to introduce myself. I'm Judith Baeta. I'm one of the head of liaison at Hub AI. And as you probably know, if you're here, Hub AI, we're a student-led organization, and our goal is to bring students from all disciplines together to just discuss and open up the conversation about artificial intelligence and its many applications and uses, and how we can all contribute to developing the technologies. We have some of the team here, Tish, Rafsan, Malika, and I don't know if we have anyone else around there without the camera, so I can't see them. But without further ado, I will leave the floor to Sverker, and thank you so much for being here today.
Well, thanks for inviting me for this this talk, and I'm going to tell you about one of my main research interests, namely to analyze language and to look at mental health with that. Let me see. Yes, how are you guys doing today? I guess everybody is muted, so nobody is saying anything, but if you would probably say I'm fine. That's what most people do. Very few people would answer with 7. Because language is obviously the natural way of communicating your mental states with. When you speak to people, or you're trying to get to know what people feel and think and do, you talk to them. But there are exceptions to this, and they are called behavioral scientists. They rather have you describe your mental states in numbers and not words. This is, in my view, very unnatural. People's natural way of communicating is language, and therefore we should also prove other people's mind with language, and not with numbers. So when we try to measure other people's mental states, which is a major question in psychology, how do we know how other people feel? Then we are kind of expecting the participants in our studies to make a transformation of your mental state into a number, so that the scientists can make a quantification of your mental states. And this is kind of a hard task, to move from how you think into a number and then present it to the researcher. So our idea is that this is nothing that we should bother the participants from. We, as a scientist, should be able to move from language to a quantification of this language to numbers, so we can do research on it without involving the participants in this rather difficult task. So this makes me move into how concepts actually are measured in psychology. So the absolute dominating way of measuring concepts in psychology are rating scales. And this is an example of a rating scales that I have been involved in creating. It's ratings of harmony, where you expect to answer questions such as, my lifestyle allows me to be in harmony or not, and you're supposed to respond on the scale. And this is basically how our concepts are measured in behavioral scientists. you measure them by scales. And the other way of doing this would actually be just to ask people, do you feel that you are in harmony and not, and let people describe your mental states instead. And this is what we are going to do here in our research of mental health. So we are interested in applying this to the mental health business, mainly because this is a major problem. There's mental health issues is causing almost half of the sick leaves today in Sweden. 45% of those people that are absent from work are so due to mental illnesses. And the dominating illnesses here is depression and anxiety. So this is a very big problem to solve, and it's something that people can relate to a lot. So what we need to do here is to provide better methods to diagnose mental health. There's a need to do that more quickly and more accurate. The earlier you can diagnose people, the easier it is to put the right treatment, and the earlier you put in treatment, the easier it is to treat. And our solution to this is to have people describe their mental states in words rather than rating scales, and to analyze these outcomes measures with artificial intelligence, so we can improve the accuracy and speed of assessment of mental health. So the basic idea here is that this should be applicable to healthcare. We should have a procedure where we are more correct in our diagnosis, and then also that we can standardize what people say. So if you describe your mental health issue to one medical doctor, you should get the same type of assessment as you describe it for another mental health doctors. So and this is not happening today, since people interpreted language in different ways, but having AI here could solve or create a standard for language, and how we move that standard into diagnosis. This will provide earlier interventions and reduce the suffering and cost in the mental health system. So what is our solution to this problem? Well, we simply ask people to describe their mental health. So one example of this would be describe if you're depressed or not. And this example, we ask people to describe in keywords. They could say that they're low, they're empty, they're separated, and they're tired. We can also have people describe how they feel in text, where they would type a paragraph or a longer text, describing why they're seeking help or why they feel like they do. And then we take this text into an AI algorithm. The first thing we do is to map the text into numbers using natural language processing system, that where you basically input the text and get out a string of numbers that describe the content of this text. And in the next step, we can use this quantification of the text to map it to diagnosis, and we can use machine learning to train a system to identify what a diagnosis is, and have the data-driven approach to classify language responses, either to being depressed or not depressed, being anxious or not anxious, for example. So in our data, we have different response formats, and it actually turns out that it's good to have different ways that people can respond. You can either write your mental health statements in free text, like describe how you feel, good or bad, in the paragraph, basically. Or we can just use keywords where we kind of simplify the expression of what people do. And then we can have it more and more constrained. We can have selected keywords. You basically click on the words that best describe your mental states, or we can use traditional rating scales. And over and above this, we can also use standard demographical data of age and gender, etc., to input our systems. And it turns out that it's actually good to have different response formats. The more different variation of response formats you have, the better accuracy you can get. It's also good to have different construct to ask that provides additional information that helps the diagnosing part. So once you ask these questions and you get the text, how can you map it to language? How can you map the text to a vector that quantifies the text? Well, there are two different ways to go about that. The more easier ones are basically based on data compression algorithm. Here you can basically input large text from a specific language and look at which words occur together in this text. And you basically make a word by word co-occurrence matrix where you see how many words occur, which words occur together in this text. And if you apply a data compression algorithm on this co-occurrence matrix, you tend to generalize the context of these words, and that creates a semantic representation of words that can be described by in high dimensional vectors, typically with a few hundred dimensions. So a word in the language basically is described by a vector with many dimensions. This process of making semantic representation, however, does not account for grammar of the text. And in order to do that, you need to use more sophisticated AI methods, where and in the last few years, there has been a great progress in this. An example of one model is called BERT. It's a deep layer neural network model with 12 layers that input text at the bottom and then tries to predict text in the forward and backward in time, or and then you use deep learning methods to do this training on. And in the last layer, you get a semantic representation that not only can describe the meaning of words, but also takes the grammar into account, so it would understand negations and various and how sentences comes about in a grammatical format. And BERT model is therefore recommended for free text data. Whereas if you just use keywords, the more simple data compression algorithms works sufficiently well. So how can we use these semantics measures for? If you ask somebody to describe their mental health, well, then we can use this to predict their mental state. We can predict whether they're depressed or not, or whether they have anxiety or not. But you can also, in a similar way that rating scales can do, but it also allows to describe a construct. So we can get empirical definition of what we mean with depression and what we mean with anxiety, and where these definitions depends on the population that you're asking, where, for instance, young and old people may have different views or different importance aspects related to depression and anxiety. And the data would there generate a representation for these mental states that are dependent on who you're asking, basically. Another aspect of these measures is tends to be very good at discriminating between similar concepts. In contrast, rating scales tend to be very, very highly correlated. So if you take rating scales for depression, they tend to measure almost the same things as anxiety. And we have shown that semantic representation are actually better in discriminating between closer concepts. So we typically do data collection online because we need a big data to be able to train our algorithms. So in our we typically use data from prolific academics website where you easily can collect people, and they also are pre-screened for having ongoing diagnosis of mental health. So we can pick out participants that already are depressed or have anxiety. And in many cases, we use like 1,000 participants for our studies. We also have connection with clinics in real and get real-world data from the clinics. So what have we found? What kind of results are we getting from these methods? In one of our recent studies, we have shown that you can actually predict rating scales with very, very high accuracy based on language data. So we have people describing whether they're in harmony or not, or whether they're satisfied or not, either in free text or in keywords. And so basically we have 4 inputs: text of harmony, text of satisfaction, and also keywords of the same construct. And we use, in this case, BERT to map the text to numbers and as well as the keywords. And then we can correlate and train them to predict the rating scales of harmony and satisfaction. And to our knowledge, this is the highest correlation in the literature for using language to predict rating scales. We get correlation of 0.85 between the predicted value of the rating scales and the texts. And this is close to theoretical limits of how well we actually can predict mental states because of limits of test-to-test reliability. If you make the test 2 times, you don't get the same results. It varies over time, for instance. There are also item-to-item variability. So one item in the rating scale may not predict other item as well, which also provides constraints on how well you actually can measure constructs. And these correlations kind of maps into these natural constraints. So we believe that we're approaching a theoretical limit of how well you actually can describe construct with language. In this study, we are looking at whether you can improve diagnosis of mental health by combining rating scales and language scales. And so we use a standard measure of depression called PHQ-9, which is a 9-item scale for measuring depression. And then we have an outcome variable related to how you typically measure depression. So the question here is whether language questions can improve the accuracy of predicting depression. So if you combine them, can you get better accuracy than if you just have rating scales alone? And it actually turns out that you can almost diminish the incorrect diagnosis by half by adding the text data to the rating scales. So the blue line here shows the limits if you just use rating scales, and the green line is how much you can improve in accuracy by combining it with language data. And the area above the curves is our errors, and that area is basically diminished by half by applying these language responses with AI to predict depression in this case. And we get similar results for anxiety data as well. So if you, in this study, we had 11 different questions, and so here we are looking at how many questions do you need to get this a good performance. And it turns out that the first question you pose provides the most information, and then the more questions you get, you don't really decrease the error as much. So this graph basically shows that the first 3 questions would provide the most important information that you need, and so you don't need more questions than that to get in high accuracy. Here are similar data with words, where we look at how many words do you need to describe your mental health, and how does the prediction improve when you have more words. So on the left-hand side, here we see how accuracy improves with the number of words. So the first word provides the most information, and after you have like 3-4 words, you don't really improve so much in accuracy. So in our recent study, we typically use 3 to 5 words, and then because that provides people enough keywords to describe their mental health. We can also look at the serial position, which word is most important for describing your mental health if you have a sequence of words. And on the right-hand side, here you see that the first word carries the most information, and the later words you mention has lower validity to your measure. So basically, we get some kind of zero position curves where the first word is more important than the later words. Since we're using machine learning, it's also important to have many data points. And here we show how accuracy is improving by the number of data points. And basically, we tend to get reliable results around 100 participants, but it improves every time we basically double the number of participants. So the x-axis here is a logarithmic scale. So the logarithm of the number of participants is somewhat roughly linear to the accuracy of our predictions measured by, in this case, correlation between predicted and empirical values of rating scales. So basically, the more participants you have, the better you can train a model to predict mental states. So another question that's rather relevant on the applicability of these methods is how participants that are answering surveys regarding their mental health, how do they feel about various response formats? Do they prefer rating scales, or do they prefer responses with free text? And which aspect of this response format do people think they differ in? And basically here we are asking people what if they what to think about describing the mental health in free text or in rating scales. And basically what we see here that the questions where free text has the most benefit over rating scales on the left-hand side is elaboration. If you write a text, then you are much more able to elaborate over how you think and feel in your mental states compared to rating scales. It's also rated more as more precise, and it's also better to reinstate the original emotional context. On the drawbacks, on the other hand, of free text responses in comparison to rating scales is that rating scales are easier and they're also faster to produce, and they're less demanding. So in summary, from participants' point of view, language is actually more precise in describing your mental state, whereas rating scales are basically easier to describe. In this context, I actually don't have a slide on this. I could mention that language responses is not only a way of measuring mental states, but it also can be seen as a way of improving mental health. There are data showing that when people write about their mental health issues, then and they do this, if they do this several times, they tend to actually improve in their mental state. And this can be done in just a few exercises. So if you write, for instance, like once a week for 3 weeks, you tend to have a better mental health than if you don't. And we actually just recently reproduced that finding that has been there in the literature before. And we argue that you at the same time can measure mental states with AI as well as treat it with these using language responses, which you cannot in the same way do with rating scales. We have also shown that, well, a concern in terms of mental state is also, in terms of measuring mental states, is the validity. What or how can we define what anxiety is and what depression is? And that's a kind of a tricky question. And in order to answer that in a good way, we used we used stimuli material that already had the predefined facial expression, and see whether and studied whether responses made with words or responses made with rating scales most accurately could predict the known stimuli of these faces. So we had faces that were either happy or sad, or shown contempt, and we asked people to describe in 3 words the facial expressions, but we also asked them for in rating scales whether they're happy or not, if they were sorry or not, or had contempt. And our result actually showed that people were more accurate or we could predict with more accuracy from the word responses their facial expressions than from the rating scale. So these data shows that actually verbal responses can be more accurate than rating scale in measuring facial expressions. We have also another issue is how well can machine learning or AI methods take a text and interpret the emotional content to it compared to humans. And in this slides, we compare the AI algorithm with humans' performance. And we show that our algorithm is actually better to interpret the mental states compared to humans. So over and beyond the accuracy of using text for validity of depression and anxiety, language responses also has the opportunity of describing mental states. So if you just take a description of what people generate in words and train them to describe either worry or depression, you can create word clouds that are basically can be seen as empirical definitions of these constructs. And I think this is interesting, not only because the word clouds looks nice, but it's also can be seen as another way of defining what a construct is. And it has advantages that it provides empirical definition of construct that is specific to the culture, the participants, the age, etc. of the participants, and which is very different from how construct otherwise is defined in behavioral scientists, where they typically are defined by criteria by researchers. And I think this provides a more flexible way of looking at concept and how they can change in different environments. We have also shown that if you use words, you can actually better discriminate between concept than if you use rating scales. So here are empirical data that are trained to discriminate between happy and sad, either based on word responses or rating scales. And as you can see here, the graph on top is more spread out. It's the word responses are better at discriminating between the constructs than the rating scales. Here's another graph showing how we can discriminate between depression and worry, which are similar concept, either by language on the left-hand side or by ratings on the right-hand side. And as you can see, that on the left-hand side, there are more words that that you can discriminate between depression on the x-axis and worry on the y-axis, using semantical scales than rating scales. And this shows that semantical scales has properties of being good at discriminating between similar concepts. So we actually have started to apply this method in real world setting, where we have people coming into clinics and they get a survey where they can respond either in text or in rating scales of how they feel in terms of depression and anxiety. And they do this before they come to the clinic. And when they reach the psychologist or the medical doctor, they receive a patient report describing the mental health of the patients. Here's an example of this, how this could look like. In this example, the patient is very likely to have anxiety on the upper hand, and to much lesser extent depression. We can also follow how this how the patient feelings are changing across time. So in this lower figures on we see that depression, stress, and anxiety is decreasing over time as the patient is being treated. Well, this is basically what I wanted to say. We are collaborating with patient organization of depression called Balance, and a patient organization related to anxiety called Ångestförbundet. And Region Skåne. And we have research grants from Vinnova and the Kamprad Foundation. So, and here are some of my collaborators. Oskar Kjell and Katarina Kjell are researchers. And then we have people that are also working with clinics related to this. So that's my talk. You're welcome to ask me questions.
I have a question.
Mm-hmm.
Philippe here. Is there any study that's tried to differentiate written text versus audio generated, like just speech versus written? I'm wondering if there's greater accuracy or nuanced differences when a person is said, how are you feeling? And they verbally describe it, or they write?
That's a very good question. We have been thinking about using verbal description as well, but we have not done that. My thinking about this is that written text tends to have higher quality. You have more time to think about what you're going to say, how you feel, and you can structure it much better. And this often becomes very obvious if you transcribe what people say in a dialogue to text. Then if you read it, it looks really terrible typically. So my guess would be that the test would have a slightly lower quality in terms of content. But on the other hand, you can extract other type of information such as tone or hesitations or like breaks. So that would provide maybe complementary information. Mm-hmm. And this is of course something that psychologist, the medical doctor also listens to other non-semantical cues in the language, and you probably could pick up these things if you do that. Mm-hmm. But I'm not aware about any specific study that's compared that yet, but that's an interesting thing to do. Mm.
I also had a question, and mine is more about when I look at depression diagnosis. Very often, women are diagnosed much more than men, and so I'm just wondering, and I don't know if it's because of like society sees women as having like poorer mental health, or not necessarily. Like if a woman goes to the doctor, very often, if they talk about pain, it's referred to maybe as psychological, it's maybe more mental. So women tend to be prescribed more antidepressants. So I'm just thinking, do you look at this gender aspect as well in your studies?
We haven't looked at it very much. You typically can discriminate between men and women with language and machine learning. But we haven't really focused on it, yeah, I think it's an open question. We do have a study going on related to age, where we see that older people tend to be easier to quantify their depression and anxiety compared to younger people. And we believe that it's related to that the language is one of the few traits that actually improves with age. And perhaps therefore they have a higher quality in their data. And we also build models on all people's data and on young people's data. And it actually, if you train on older people's data, you actually the model that you create can actually be applied to young people's data with greater accuracy. So getting back to your question, women tends to have higher language abilities. So it could be the case they actually have higher quality data for training models for mental health on.
Okay, interesting. Because sorry, just to follow up, because I also saw the PHQ-9. I think I can't remember. Like they were checking if German men, for example, like on German men, and if you could actually calculate depression on the PHQ-9 questionnaire. Is this like right? Anyway, and they were like, actually, this questionnaire is done in such a way that women like how women show depression. That questionnaire is quite good, but for men they tend to externalize it in a different way, how they show depression. So it might be like through anger, through addiction, through so do you feel, I don't know, do you take that into account as well in your model, or I don't know?
Well, I mean, the model would pick this automatically if you, presumably, if you just have the input data there.
Yeah.
And I think you're quite correct that there's different traits. As you're mentioning, men are more aggressive, for instance, that the model probably would pick up, but we haven't really focused on that question, so I don't really have a very good results to say about that.
Thank you. It's very interesting. Thank you.
I have a question. So I was wondering that you talked about data collection online and people assessing their own mental states, right? So I was wondering that whether or not that kind of training data is reliable for a model, and whether or not if there's a gold standard for it, or if how it differentiates between clinically acquired data and self-reported data.
That's a good question. So it's kind of like an ongoing problem in this in mental health. How do you best measure mental health, basically? And if there is what people probably would say is a gold standard would be a lead methodology. Lead means longitudinal expert all data type of study, where you basically look at a patient over time longitudinal. You have experts, meaning people that have worked with mental health for years to evaluate the data, and you have all data, meaning you have data of what's happening later in time compared to when you maybe want to diagnose something early in time, so that would and that you have also different data sets of not only service but also like interviews and sick reports, etc. So that would probably be the gold standard, and that's something we are actually working on collecting at the moment, a lead study, and hopefully that will provide more accurate data to train on. But then there's also a question whether what is the best? Is it better to have just a larger data set with some noise in, or a smaller, or that is easy or cheap to collect, or a smaller data set that is very accurate but less in size? So that could, it's we don't really know what, that's an issue we can think about in this context. But we will have more information about this in a short while. Melika?
Hello, I realized that you proposed a question before me, actually, so I would let her go first, because I'm still kind of forming my question.
Okay, yeah.
Okay, thank you. Yeah, I had a question, and it's kind of related to the quality of the language that you were posing like, yeah, how that matters before. And yeah, my question is like, if you've seen any effect of having non-native speakers describing, because they, like us as non-native speakers, tend to use like more simplified language. So I don't know if that can affect the model somehow.
Yeah, we don't have good data on this, but we have proxies. For instance, you can look at language word frequency of language, where the idea is that people with high proficiency would use more unusual words, like lower frequency words, and so one idea is that people with low frequency words that are high language speaker would have better communicate the language than people with high frequency words. But then there is also this alternative explanation that the model that you create is probably picking up high frequency word better because there's more training data on that. So maybe that's more informative for the model. So if you look at the error and relate that to high and low frequency words, it actually turns out that there's a negative correlation between word frequency and errors. So it's actually the high frequency words that tends to be more provide a higher validity than the low frequency words. So we are thinking that could be a model issue rather than a concern of the knowledge of the people that are describing the mental health.
Thank you.
Mm-hmm. I guess I could go now. First, I want to say thank you, Sverker. I'm very excited to have psychologists here because I've been here in Hub AI since founding moments, and this is the first event we have on psychology related to AI. So I'm very excited about that. And I have two questions. They may take a few minutes, I don't know, but I'm curious first to hear, did you do your research mainly in English language or Swedish language?
Mainly in English because it's easier there are better data sites for that, but we've also done in Swedish.
Mm-hmm. Yes. I'm asking because I was thinking of some language aspects of this research of yours. It is a very novel research and it may be rather early to talk about these things, but I was thinking if we would use this method in other countries, in other languages, etc. This may be a very technical question though. Would there need to be a new system, like entirely new system developed for every separate language, or you would just embed a translator system into something that is already existing in English? I hope I was clear with my first question.
Yeah, the question is clear, and we kind of looked into this a bit, but I don't think I have the complete answer to this. But it actually, I could say that this is possible to just, for instance, you use Google Translate and go from one language to another language. You probably lose some accuracy somewhere in that process. And exactly how much you lose, I wouldn't want to say at the moment, but you can do it, and you get reasonable good results, I could say. Mm-hmm. Exactly how much you lose, I could not. I don't want to make any claims regarding that.
Yes.
And then as you probably are familiar with, there are also, I mean, some of these deep learning models are multi-language, so you can input things on one language or on different languages at the same time, and then you get a model for that translate into other languages.
Mm-hmm. Yes, I was just generally thinking what would be the most convenient thing if someone would aim to use this research in their country, because it seems very useful. And my second question is more methodological, from psychological perspective again. So I had to write it down actually. So you said that the more questions we add in these measures, the accuracy improves for obvious reasons for machine learning, just by higher numbers of words given by participants when they are reporting on their states of depression and anxiety feelings. But as we have background in methodology, we know that the more questions we give, there's a danger that participants will get fatigue, or that reliability could be falsely inflated. So what proved to be the golden average of number of questions in your practice in this area? So taking into account both psychological reasons for our participants and machine learning requirements.
Yeah, we don't really have good measures of fatigue, so I can't answer that very carefully. But what I could say is that very generally speaking, you don't need so many questions, or people don't have to write so many words. So I think you can get kind of good accuracy with fewer questions than we have done in many cases. And I mean, I think one of my slides showed like we post like whatever 11 questions, but you could get good enough information from like maybe 3 of them. So I would actually go for a smaller number of questions in terms of that. And I also think that is a major advantage with language. If you want to know how somebody feels, then if you ask how do you feel, that you could very quickly say, oh, well, I'm drinking and I feel like hangover. If you would use rating scales for that, then you have to have many different rating scales before you get into a drinking rating scale that would measure that. So I think language has the opportunity to like more directly go into what people have on as a priority in their issues.
Yes, thank you very much.
Rafsan.
Yeah, I noticed that Philip raised his hand before me, so like, go ahead.
It's okay. Go ahead. You go ahead.
Okay, thanks. I just had a very small question. It may be a bit technical. So I was wondering that you mentioned about BERT models and attention-based models. And a lot of these models are usually fine-tuned on certain types of data, but they're already pre-trained before. So I was wondering that, have you noticed any significant difference between, say, like the original BERT-based model or SciBERT, or, you know, models that have been pre-trained on a specific text, and have the accuracy of your models developed over, you know, these kind of pre-trained models?
Well, we have actually not played around with so many different models or pre-training. So we basically use like the standard BERT model. So I don't have any empirical data to answer that question.
All right.
Yeah, I had 2 ideas. One was actually just triggered by what you just mentioned. I was just reading about these new kind of approaches called generative adversarial networks, or GAN, which I'm wondering, those are relatively new in the past 5 years in machine learning. And I wonder if that would, because you use one neural network to generate categories or classification, then use an adversarial network to actually challenge and refine what the program developed. That was one thought. The other thought that I just wanted to share was, having used these tools to try to classify depressed or anxious or not, 1-0, as a psychologist and also a treatment intervention psychologist as well, and neuroscientist, the next thought is, and when so many people are interested in underlying mechanisms, and would it be possible to actually get people to describe when they're being treated for depression, what is actually changing, and then applying these tools to their text to try to decipher or extract mechanisms that we often, when we do our analyses, we assume that there's a mechanism, but maybe we're missing it. I mean, that would be a wonderful next extension to actually, over months, try to use people's self-report to try to identify underlying mechanisms of why people are getting better with medication, psychotherapy, physical exercise, meditation, et cetera, et cetera. I would love to dive into that.
Me too. So yeah, I fully agree that it would be very interesting to see, like before and after treatments, description of your mental states, depending on what the treatment is, for instance. Or I mean, for instance, if you do psychotherapy, dynamic therapy, you probably would develop other language skills than you do cognitive behavioral therapy. Or if you just take medication, you probably maybe not develop language skills at all, but you may feel better due to other reasons. So, I don't think studies like this has been done, and they're a bit more demanding to do, because you have to involve people that are in therapy, etc. But it's quite doable. So I think in the future we'll have data to answer that more carefully.
Well, it's 6 p.m. I don't know if anyone has any more last minute questions. Maybe we can take one more, but if not, maybe we'll leave it here for this evening. Like 5 seconds. 5, 3. Okay, no more questions. So thank you everyone for joining today. And thank you, Sverker, for your presentation, and also everyone who brought questions to the discussion. I'm sure, well, I found it super interesting. I hope you did too. And yeah,
Thank you,
everyone.
Thank you.